So we're getting into the VPS. This is going to be a very in-depth, thorough video on everything VPS and integration to Holley Efi. So this paper, this screen that we're looking at right here comes in paper form when you purchase a VPS, as well as the next screen that we're going to look at. And I just wanted to go over with you what all of this is, because this is the order in which I believe you should go about installing this. So this is a diagram showing you what pin does what. Starting from the top, with Holley Efi, I like to power this VPS and the profiler off of B20 on a Dominator. And so here's your red wire for B20, black is battery ground. That's your first two that you should be taking care of. The ones that are not highlighted, as you can tell, are included but not installed in the connector. They plug right in. Just decide if you want to use them or not. The serial RX and serial TX is strictly for an existing profiler, not the profiler module, but a profiler. So we're going to skip over serial. We're not going to use that. And I have yet to use this right here, pin 11, blue, general purpose output. So what we're really looking at is the analog outputs, right? 1, 2, 3, 4, and 5. And the trans brake sync in. You also are going to want to use an arming switch. So you can use, what I do is I have a switch in the car to arm the VPS, arm the profiler. It actually turns on the boost control solenoids. It does a bunch, but it's all in how you wire it. So your arming switch is going to be ran to pin number 5, which is a tan wire. Your trans brake sync in, you're going to tie into the same wire that you are using for your trans brake input, or you can create an output in the Holley to send to this to let it know that, you know, hey, we're on the trans brake, hey, we're off the trans brake. So what that trans brake sync in does is it actually zeroes out the VPS unit so that when you release it, it has a 0 number to base itself off of, and we're going to get into that a little bit later. So analogs is what we're interested in mostly. Analog 1, 2, 3, 4, 5. So look at these outputs. These are 5-volt outputs, okay? So 0 to 5 volt. And this is how we're going to monitor everything that the VPS is telling us into the Holley. So these are the wires. So if you're going to use analog 4 and 5, then you're going to want to insert, you know, these into the harness. It's very simple. And then here is a diagram that Shannon has come up with, and we're going to go over it and show you what it pertains to for Holley. So it's a little bit blurry, but as you can see, like I just described, trans brake right there, an arming switch, so you can turn it on and off, battery ground. This isn't a specific Holley EFI one, but it makes sense, and obviously the VPS works with everything. I'm just more apt to teach y'all Holley than anything else. So here is our 5 wires, and replace data logger here with your Dominator ECU. So this page also comes with the purchase of a VPS, but I just wanted to show y'all so you kind of knew what you were getting into. It's going to be 5 analog 5-volt outputs from this, which turn into inputs at your Dominator ECU or an HP. So this, just know you do not need to supply sensor ground and 5-volt reference here, okay? Which is actually really nice. So no more having to splice into your harness and add 5-volt reference and a sensor ground here. It all comes out nice and clean from the VPS. So once we've got this wired up and we've and we've got maybe we've got 5 loose wires hanging here, all this stuff is done, but we've got 5 loose analog outs. What we're going to want to do is we're going to go into the Holley software, and we're going to go to input and output, okay? So we have to create our inputs so the Holley knows what we're looking for. So all of the G meter stuff that's in the VPS is plus and minus 5 Gs, okay? So here we're gonna look at, we name this VPS x-axis. It's a 5 volt, and we're gonna enable, and then we're gonna configure. So this VPS x-axis Holley 1 bar, okay, so what did I do here? I had it all set up. Here we go. What we're going to do is we're going to go all the way to the bottom, custom 5 volt unit. Geez. Format, we want some pretty good resolution, so 1.23. So the sensor minimum is -5. So, what are you doing to me? -5. Sorry, it's late. And I've been at this all day. And then sensor maximum is 5. All right. Now, we have to go to our calibration table. So if you look, we've got 0 volts here, 2.5, 5 volts here. All right. So 2.5 volts is 0 Gs. Plug a 0 in there. 5 volts down here is 5 Gs. So plug a 5 in here. Okay. 0 volts is -5 Gs. Now what we do is left click and hold, drag it on over to 0, right click, fill row values. Then we're going to left click and hold at 5 Gs, hold it and drag it on over to 0, right click and fill row values. That's it. That's all you have to do to set up the input for the VPS. So that is for any of your G meter readings. Now we've got yaw, pitch, and roll here, okay? So these are plus and minus 12 degrees. So if we go to configure, these are already, I already did these. But what I did here is we used unit degree, okay? Format 1.23, sensor minimum -12, sensor maximum +12. And then we've got our 2.5 volts, which is our 0 point, and 0. And we, again, just left click, hold, and drag to 0, and do the same thing on the other side. So the reason you don't want to do this, if you watch what we do here, watch all the numbers. If we fill row values, it just moved everything. Because we've got 15 cells, and it's an uneven number of spots for in order to interpolate between the two. So we're going to undo that. Oh, I just tanked that. Whoops. We'll redo it here. So it's simple. 12 degrees. This -12. And then we find 2.5 volts. Right click, fill row values. Same thing here. Right click, fill row values, and we're back to square one. So if you get really tired and you fat finger something, it's extremely simple to fix. So anyway, there is our input setup, and we'll do the same thing for yaw, pitch. Okay, same thing with pitch. See how this looks a little goofy? See how it's a little jump there? That's because it was interpolated between here and here. So let's fix that. Notice this was also interpolated, okay? There we go, and there we go. So again, it's left click, hold, right click, fill row values. So now we've got a few of our inputs done. you're going to go to, once you have them all done, okay, so plus or minus 5 volt for all of your G meter stuff, and plus or minus 12 degrees for yaw, pitch, and roll. Once you do that, you're going to go to pin map. And it's as simple as every other pin that you've done with Holley EFI. These inputs will be created here. You'll click them, and you'll drag them and drop them into whatever pin you have wired it to. So setup for this when it comes to Holley EFI is actually really easy when it comes to actual installation. The utilization of this can get very complex, and it also can be very simple. So we're about to go over some of that stuff, so hang tight. And I'm going to show y'all how to use this for a wheelie control with Holley EFI. I'm also going to show y'all how to set up all of the outputs from the VPS that become an input to the ECU. So the first thing we need to do is decide what our outputs that we want to see on the ECU are going to be. So in the remote display, go to set outputs, and it gives you 1 through 5. So in the blue boxes, it says output 1, 2, 3, 4, 5, and then there's numbers underneath of it. So this is, it can be a little confusing. So I just tend to write it down, what we pick as an output. So output 1 in mine is actually the built-in wheelie control, and we're not going to get into that. But if you want to use the built-in wheelie control, Shannon sells it for, I believe, $700. It's worth it in my opinion, but a lot of y'all are going to want to try to do this on your own without it, according to all the messages that I get from everybody. So I'm going to show you the other way to go about it. The difference is his wheelie control, retard, and smart drop is a lot more capable than what we'd be able to pull off in an advanced table, because it has a return rate and it also has the ability to enable smart drop. So we're going to skip 1 and we're going to go to output number 2. So when you look at output number 2, you have a list here of things to pick from. And earlier in this video, I showed what all those actually mean, but what we're going to do is we're going to choose accelerometer X, which is the X-axis, for our output number 2, which is selection number 1. So we wrote that down right over here, and we're just going to continue going through the rest of the outputs. So output 3, we chose number 6, which is the gyro, the Y-axis, which is, or I'm sorry, the gyro yaw. So we wrote that down. Output 4 is selection number 5, which is roll, gyro roll. And output 5, here we go, is pitch. So we have our outputs selected, we wrote them down. All right, so our outputs are all set up, and we are about to start making some advanced tables to use for this. So in the display, you'll be back at the main menu, and you're going to have to hit Utilities, and then you're going to have to hit Live Display. So on this, you'll see at the top left, we've got the accelerometer, which is, sorry, there's a little glare in here. It's pretty bright in my garage. X, Y, and Z axis, but what we're going to be looking at is the top right corner, the gyroscope P, pitch. So what I'm going to do is I'm going to go jack this car up and just kind of give you a quick demonstration, and then we'll pan over and show you the whole table that we built around this. But we're going to, let me jack this car up and take a look at what happens. All right, so we've got a pitch of 1.2 degrees. So that may not seem like a lot, but take a look at the car. If you look at the car, here we are, lifted off the ground a little bit. Tires are off the ground at 1.2 degrees. So we built a table around, or we built a little diagram around what we're calling front bumper height, which I just measured off of that little hook there. And again, off of tire height. So this tire's off the ground, but barely. And I've got an entire table right over here that we put together. So what we did was I wrote up, well, I didn't write it, my girlfriend wrote it, but the degree of pitch, the height of the front end, and then the height of the tire. So we've got 0, which is resting, ride height. The front end is sitting at 6 inches. Once we reach 0.5 degrees of pitch, our front end is at 7.5, but the tire is still on the ground. We don't remove the tire from the ground 1 inch until we're at 2.0, okay? So this is all dependent upon ride height. So you have to understand that when you take these measurements, you have to be in the car and, you know, ready to race. So that's why this number here is a little different. 2.0 is a little different than the 1.2 that we just saw on the display, where we had a tire about 1/8 of an inch off the ground. But as it would increase to 2.0, we would reach 1 inches of tire travel. So this is the actual tire off of the ground. This is the height of the front bumper. So you can build yourself a table all based around how much pitch you have to how much height on the front bumper and how much height off the tire. So 12 inches of the tire off the ground may not seem like a lot, but the bumper is 2 foot in the air, and that's going to come down kind of hard. So by doing something like this, it gives you a pretty good baseline of how you want to use this to retard timing in order to stop you from wheeling. So what you would do is you just fill in the blanks for how many degrees of retard that you would need. What we're going to do is I'm just going to slap together a pretty basic idea of what I feel like is going to control this car, and I'm going to show you that here in a second. All right, so we've got our VPS all wired in. It's all configured. We've got our inputs assigned to where they belong. Down here, we have them all configured. In here, right here, like this. And now it's time to actually put this thing to use. So not only are we going to monitor all of these different axes and whatnot, we are going to make this car wheelie, or at least attempt. So we're going to get into our advanced tables. So the advanced ICF right here. And I did this 2 different ways. So this is going to be one of those things that you're going to have to play with, and you'll have to come up with a strategy that works best for you. But this is a rough start here. So go into your 1D tables. And here is the table, the first table that I created. So we're going to enable the table, name it VPS wheelie. The table type is a timing offset. So when you click in here, there's a whole bunch of different types of tables that you can use. Click timing offset. And then the x-axis is VPS pitch. Okay. So pitch is how high the front end comes, like we were just talking about. And what we have here is a scale, just the same way we scaled the input, right? So minus 12 degrees to plus 12 degrees. But we're more concerned with the positive number, correct? So we don't care about the negative. So let's start that off at 0, all right? And from the video I showed you, or part of the video I showed earlier, at 8 degrees of pitch, the front end was 24.75 inches off of the ground, and the tire was 12 inches off the ground. So in a turbo car, that thing's going to flip over if you're starting to roll the power in. So we're going to leave 12 as the last number here, and I'm going to put 7 degrees here. And the reason I put 7 degrees here is because we've got 14 numbers here, and it's going to make this a little easier to explain. So left click and hold, drag it on over from 0 to 7, right click, fill row values. So right here we've got, this is degrees of pitch, okay? So if we refer back to our table, the front tire didn't start coming up off the ground until we had 2 degrees of pitch, okay? So if it's just skimming along, there's a good chance we don't need to make a modification to timing here. But if it starts to climb, we can start removing some, okay? So we may want to start off a little soft, and we can put in -2 degrees. And the quick way to do this, when we get to 7 degrees of pitch, we want to knock 20 degrees out of it. Now, you nitrous guys are probably not going to want to do that, but you will probably want to grab, nitrous cars are going to want to grab it quick. A turbo car, you may want to grab it a little slower. So what I did was I started at, pulling 2 degrees of timing out of it at 2.5 and pulling 20 degrees out of it at 7. So what we're going to do is we're going to left click, hold, and drag on over to 20, right click, fill row values. What we did there is we removed timing gradually as it started to climb. So if you think about this, if the car starts to climb and it reaches 3.5 degrees of pitch, we've got 6 degrees of timing out of it. The goal here is to make it come back down, okay? So once we increase some wheel speed, further on down the racetrack, as it starts to set back down, it'll gradually come back into full power, right? So after I show this next table, there's another caveat to this, which is the rear extension, which you're about to see. But this is a simple, basic way of doing this, right? So that we have a timing retard based off of pitch from the VPS. And the goal here is to, if it starts to really climb up here, it's going to start really killing power out of it. It should set the car back down. These are numbers that you're going to have to come up with on your own. You can take what I just plugged in here, but I'm going to tell you right now that I spent about 45 seconds deciding on what numbers to plug in here. Don't take this as the gospel. So if we get over 7 degrees of pitch, this thing's really starting to climb. So let's knock -25 out of it. So what it's going to do is it's going to interpolate between 20 at 7 degrees and 25 at 12 degrees. But again, these numbers are something that you're going to have to play with. So as you look at a data log after a pass, if the car did wheelie, you may see that it took 12 degrees to set that thing back down. So you may want to start taking some timing out of it a little earlier, okay? So you may want to try to get a little bit more aggressive with it, with timing removal. Now, the second way to do this would be a 2D table, okay? So go to 2D tables and go to timing offset. Again, I named it wheelie 2. Your x-axis is VPS pitch, and your y-axis, I chose driveshaft speed. So if the car is, driveshaft speed's like 7,000 RPM, it is not as prone to want to continue to climb. So we already know that it's 7 and 12 degrees no matter what the driveshaft speed is. We don't want that, right? So we don't want it, we certainly don't want 12 degrees, right? So let's knock 25 out of it. And again, I'm pulling these numbers out of thin air, all right? So don't just take this as the gospel. This is something you're gonna have to play with yourself. Also, before I get too far into it, drive shaft speed, you're going to want to scale this. Okay? So 10,000 RPM, if you had a lockup and an import with 4-cylinder or something that you were revving at 10,000, maybe that would be relevant. But in reality, let's scale this thing down to 8,000 RPM. Or if you want a lot of resolution at lower wheel speed, because the car should set back down after the 330, you can change this thing, lower it even further. Or you can set up your input for drive shaft speed in mile an hour and do it based off of that. So we can left click, highlight all of these rows, right click, and then fill row values, fill column values, and clean this up a little bit. So 12 degrees, we're pulling, or 12 degrees of pitch, we're pulling 25 degrees of timing. We know that the lower the drive shaft speed, the slower we're moving, right? So the more prone it's going to be to climb the front end. So if we start here at 2.5 again, and 0, we should have nothing here. We really shouldn't because the car's not moving. But it's going to interpolate between 0 and 533 RPM. So if we start at 2.5 degrees of pitch and maybe up to 3,700, we're going to pull, we'll pull, let's say 4 degrees out, right? So we're going to pull 4 degrees out across 2.5 and 3.0 degrees of pitch. And a quick way to do this would just be left click, hold, highlight all of this, and then right click and fill row value. So rows are horizontal, columns are vertical. So fill row values, and now we've got a nice pretty graph here of timing removal ramping up to 25 degrees removed at 12 degrees of pitch. As drive shaft speed increases, and again, you're going to have to look at some logs and learn this stuff, but as drive shaft speed increases, the likelihood of the car climbing is less. So maybe we don't mind 3 degrees of pitch, and we really care about 3.5. So at 3.5 up to, say, this area, 6,400 RPM, we're going to want to hit it with maybe only 2 degrees of timing removed. And then we can do the same thing. We can interpolate. Right, so fill row values. And now we've got another section. Notice the change here in how much timing is being removed. And we can do the same thing up here, but we can be even less aggressive with it with this much drive shaft RPM. So there's a really good chance that you're not going to be wheeling the car at 8,000 RPM drive shaft speed, but it doesn't mean we don't have the option to try to control it. So if we've got it, let's use it, So we can plug 2 degrees in here, and we can fill row values. So down here, we're not doing anything, right? So under 2 degrees of pitch, we're doing nothing, okay? So anywhere in this table under 2 degrees of pitch, we're not doing anything. Above 4,267 drive shaft RPM, and not until 3.5 degrees of pitch, we don't do anything, right? So all this is a dead zone. We're not taking any timing out of this. So you could also, if you wanted to, you could replace, drive shaft speed with, let's see here, boost time. So this could be the time after the release of the trans brake. So you can make this a 6 seconds as your peak, right? And we can make a timing curve to combat wheelies based off of the amount of time after we release the trans brake. So if it's a little easier for y'all to understand that, say this car goes, 280, or, plug in a number here, say 290 to the 330, right? So all this area up here is past the 330 in like an 1/8 mile race, right? So after the 330, we may not want to do anything, right? So we can leave all this blank. We can zero all this out, And then we can work aggressively here in the first 0.8, right? So 0.8, if we get beyond 2 degrees of pitch, 0.8, and we get all the way up to say 5 degrees, we want to slam this thing down. We want to shut it off. We do not want this car to wheelie for whatever reason. We pull 10 degrees out of it. So we're going to club it in the head with 10 degrees no matter what. So here, whoops, I missed a row. And then as time increases, we're going to lower that number. So say, out to that 230 or that 330 number at 2.80, we're going to make this only 4 degrees. And we're going to left click, hold, highlight this whole thing and hit fill column values because it's vertical. Now we've got an area up to the 330 that is, it's more aggressive than we were, but our axis has changed. So shorter into the run, we're going to hit it even harder. Well, here we have to be even more aggressive. So maybe we decide that we're going to make this 14 degrees, and if pitch gets up this high, we're going to hit 16 degrees. And again, these numbers I'm pulling, I'm pulling out of thin air, so don't take these as the gospel. And all of this stuff can be adjusted however you want. If you find yourself, the car just doesn't ever really, the pitch never really goes anywhere, it's time to hit it with more power, right? So make it rise. Make the front end start to travel with more power. Get the power in earlier, get it sooner. So that's how you're going to get faster, is getting the power in quicker. So now it's time to show y'all some rear separation and how everything I just taught you all plays into the entire basis of the car and why this VPS is more important, in my opinion, than a ride height sensor. One thing we left out of our chart behind me is what happens when the car actually accelerates. So you let go of the trans brake on a radial tire car, and the chassis, the body of the car, is actually trying to lift up, right? So we're driving the tire down, but what happens is the rear end separates depending on how you have the suspension set up. So when you have a bunch of anti-squat in the car, it starts to climb. So what that's going to do to our pitch number is it's going to give us a different starting point, a zero angle, if you will, according to our chart that we made. So you have to take into account how much separation the rear end is actually going to have when you make a pass. So you've probably seen cars where you've got 3 to 4 inch gap in this quarter panel to the tire when it's 60 to 100 foot out. So that's all going to come into play. The best way to do that is just like we did the front. We're going to jack up the back of the car and lift it to a point where we feel as if it's going to be at its full extension, and then we find our 0 point and we start jacking the front end of the car up. So the way I showed you before is a good starting point, and then you'll slowly start to add more negative pitch in order to get a more accurate starting point. So that's all I got for you guys. Have a good one.